Okay, Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. Assalamu alaikum. Quickly go to the topic, okay? We were doing differentiation, and in this one, if we are getting these type of the question, I write it. This one is wrong. Yeah, this type of the equation. When you look at the first glance, maybe it's looking little difficult, but check it properly. That leave it as it is, no problem. Yeah, we have to differentiate this one. If we apply directly the differentiation method, so power rule as a whole, the terms are going to infinity, and as a whole there is a square root. But we can do this one. If directly we apply power rule, so power will be in the start, power minus 1, and the derivative of only, yeah, without power only, without this power, derivative of all this. So again they are going to infinity. Going to infinity means the derivation will never come to an end. It will go to infinity if we just go directly. What we can do, just a small trick we can apply, that at least can we cancel the first term power? How? Take square on both sides. Square root. So taking square on both sides, just a small tip, taking square on both sides, this will become y square, and this will become just one term will come out of the square root, tangent of x, plus this again tangent x plus tangent x plus so on infinity. If the terms are going to infinity and you are decreasing only one power, is it matter? It will matter? It doesn't matter. It doesn't create any difference. Infinity means countless number of terms. It is going to countless number of terms. So I just take one term outside, remaining still going to infinity. It doesn't matter that how many terms it is going as it is. So using the same trick, can I write it like, because still it is going as it is, can I replace it with the term y?
Yes.
And quickly our expression become a very simple expression.
Yes.
Yeah. So this is just a very small trick to change it into the simple expression. And now this is y square. If I want to bring it over here, minus y tangent of x. Equation is implicit function, but can be easily differentiate. Okay, now differentiate with respect to which variable? X involved. Okay, d by dx on this side, d by dx on this side. What happened now? This will become, when I apply d by dx on this one,
2y.
let me write it. I don't want to put you in trouble. Okay, power in start, power minus 1, and the derivative of the function without power. Okay, minus d by dx on y
Yeah.
equals to, what is the derivative of tan function? Secant square. Secant square of the function, and then derivative of the angle. Derivative of the angle. Speak about the true relationships. Whenever you are speaking, so there will be less chances of mistakes. Power in start, power minus 1, and derivative of the function without power or under the power. Okay. Now derivative of the function, because it is only single function. Now tangent angle, whatever the angle. Secant square of the same angle and derivative of the angle. Okay. So 2y and dy by dx minus dy by dx equals to secant square x. This is becoming 1. So we can write it 1. It's okay. dy by dx, can we take common?
Yes.
Okay. dy by dx, if I want to take common, so common 2y minus 1 equals to secant square x only. So if I shift this over here, this derivation can be solved. But they have given you to prove like this in this form. So we have to check that either our derivative is in this form or not.
Yes.
So it is in this form. Okay.
it is.
Only they have written in the start. So whether you are multiplying from the left side or the right side doesn't matter. Okay. So you can change your answer exactly as they are asking it from you. So it's done like this. Okay.
Yes.
Next question. Question number 7. What is that one? The next type,
Question
like
number
it was 7.
Yes.
Oh, I write it 6. And this is 8. Okay. That is if x is equals to the function. Now I will ask a question from you. Get ready. Y is equal to b sine of cube theta. Okay, tell me. What type of the equations these are? Which type of the questions these are?
Well, with the variable.
My dear, parametric equations. Okay, because the third variable theta is involved. Theta is involved. Okay, how to solve parametric equations?
Chain rule.
Chain rule, exactly. We will take the help from the
Chain rule.
chain rule. So keep all the points in the mind. Okay. Not going up. It's okay. Now, this will be differentiated with respect to theta. This will be differentiated with respect to theta. Let me take this one first. D by d theta on this. Yeah, d by d theta on this function. A cos of
Q.
theta. Good. A is a coefficient.
Yes.
Apply power rule on this. Power in star,
Cos.
power minus 1. And derivative of
Theta. The angle.
a function.
Function. Okay.
Cos of theta.
Cos of theta.
I was telling you when the power is on trigonometric ratio, it means it's a whole power. When the power is on angle, so consider it's the power of only the angle. So power is on complete function. Okay. Now 3a cos of square theta. And what is the derivative of cos? Minus of sine. Sine theta, it's negative sign I can write in the start.
Yes.
And derivative of theta will be
One.
1. So this is the
Okay.
derivative of the x function. Okay. Take y. Y is equals to Walaikum assalam. Y is equals to, what is the value of y?
B sine cube theta.
B sine of cube theta. Again differentiate it with respect to
Theta.
theta. Good. D by d theta. Because you have to differentiate with the variable involved.
Yes.
So the third variable involved in this question, that is theta. Theta will be behaving like a parameter. Means you have to go to eliminate this theta. Okay. Then your derivative will be obtained. Now dy by d theta. B constant, a coefficient. Power rule.
Yes.
Power in start. Power minus 1. And derivative of
Sine theta.
sine theta. Good. 3b sine of
Square.
square theta. And what is the derivative of sine?
Cos theta.
Cos of theta. Equation number 2. And it can be said as equation number 1. Now when we are applying our chain rule with the theta involved. Yes. So now, where is my second pen? Thank you. Chain rule dy by dx involving theta. Okay?
Yes.
Theta involved here, if you forget.
D theta.
Okay. dy by d theta, this value.
Yes.
3b sine of square theta cos of theta. Here we find out dx by d theta.
1 over.
Dx by d theta. So reciprocal of this we will use to put the value here. Reciprocal means 1 over minus 3a cos of square theta and sine of theta. It's okay?
Yes.
Now which cancelling?
3.
3 to cancel to 3.
And cos.
Cos
And cos
cancel with its square. Yeah?
or
Means
sine.
1 cos cancel.
Yes,
Sine also
sine.
cancel 1. So what is left? B over a
B over A.
minus sine
minus-
overall.
Yes.
And sine theta
Sine theta over cos theta over cos theta.
over cos theta. This is dy by dx. We have to prove in this question. Proof value is, what you have to prove?
A dy by dx.
A dy by dx plus b
tan theta.
tangent of theta
Equals
equals 0.
zero.
Yeah. Derivative is done till here.
Yes.
But when we have to prove, we have to make the formation like this. dy by dx have the product with a.
Yes.
So can we shift this a on the other side?
Yes.
Okay, so shift a on the other side. dy by dx minus b stay here. Sine by cos they change into tangent form. So we can also change it into the tangent theta form. Now they shift this term on the other side of equality. So negative will change to positive.
Positive.
So exactly our formation is done. We have achieved the formation given by the question. Okay, so it's done till here. So differentiation is very easy. Only what you have to keep in mind, always power rule,
Power rule.
parametric function. If parametric functions are there,
You have to use chain.
then use
Chain rule.
chain rule. And
And
derivative of ratios,
yeah.
all ratios, you must keep them in the mind every time. Then product rule,
And question.
yeah, product rule and quotient rule. If you are keeping these things in the mind properly, then your differentiation will be perfectly all right. Differentiation will be perfectly done with star. Okay? So keep in mind always power rule, parametric functions, then apply chain rule. Product rule, quotient rule. If you are getting more than one function, more than one variable. Then derivative of the ratios. Whatever the ratio involved, you must know how to take the derivative. Okay? Basic ratios derivative you must know. Then your differentiation will become easy. Okay? Now, until now, the simple derivatives are almost done. One more question last left. I will explain that question also, because that is also just taking a formation. So continue with that question easily. Number 9. In this one, x is given as a time cos of t plus sine of t, and y is given as
A sign of
a sine of t minus cos of t with t also.
with T. Yeah.
Yeah. So differentiate with respect to t.
Yes.
Dx by dt,
T.
a times a is constant, d by dt of the full function cos of t plus sine of
T.
t. A as it is. What is the derivative of cos?
It is minus sign.
Minus sine of the angle.
angle.
And dt by dt 1.
Yeah.
What is the derivative of sine?
Cos.
Cos t. Okay? So leave it as it is.
Okay.
Number 1 equation. Take this one. Y is equal to a derivative of this one.
Yes.
D by dt. I'm going to do it little faster pace. Okay? A. Derivative of this?
Cos T.
Cos of t.
Yes.
Directly. Okay? Minus.
T.
Now this one is product, my dear. T is
Product.
also a variable. This is also a trigonometric ratio with the variable angle. So need to put the small bracket.
Okay.
T as it is.
T. Yes.
Derivative of second function
T.
plus
Okay.
cos t as it is. Derivative of
Of the
first function.
Yes.
Now a cos of t minus t as it is. What is the derivative of cos?
Minus sign.
Minus sine t. Very good. Plus.
Cos T.
Plus cos t
1 plus 1.
1. No need to write that one. It's okay.
Yes.
Cos t minus minus plus
Plus
sine t into t.
Yeah. Yeah.
You can write it in the start also if making any confusion. Minus cos of
Minus T.
t. They can be cancelled.
Yes. Yes.
So it left a
T.
t
Sine T.
sine of t.
Yes.
So apply the chain rule now.
Yes.
dy by dx equal to dy by dt dt by dx. Good. dy by dx equals. What is dy by dt from the second equation?
Yes. A dot T.
A t
Sine T.
t sine of
T.
t. What is the derivative of this one? We will use its reciprocal.
over
Yes.
L1.
1 over a minus sine t
T plus
plus cos t. Only a cancel.
Yes.
So t sine t will stay in the numerator. And can I write this first?
Yes. Cos T minus sine.
Okay. Until here the derivative is done. Now we have been given a proof in this section or not?
No.
No? Only dy by dx?
Fine, yeah.
So this is okay. Done. Derivative of this function is done. Okay? So thank you so much. Inshallah, I will start the next topic in my next video. Allah Hafiz.